Hi, my name is Sam. I'm the founder of Mastra and the author of Patterns for Building AI Agents. So in March, we wrote this book called Principles of Building AI Agents, and it actually became much more popular than we expected. It was a guide for people who are kind of new in the field of AI engineering. Today, we've printed out over 100,000 copies and given them away for free. One of the questions that people asked us, though, kind of like, okay, great, I now understand the fundamentals, but what do I need to know as I'm sort of bringing my application into production? A lot of the things that we talked about in Principles could be illustrated with like simple code examples, whereas a lot of the things that we were talking about in Patterns were more conceptual. They're almost more processes for improving your agent accuracy and refining your evals, doing context engineering. So I'd like to share with you a few of those points. So the first thing that we encourage folks to do is to whiteboard out their agent capabilities and how they want to architect their agent. A lot of times you get a lot of different people wanting different things out of the agent, and it's useful to whiteboard things out so it's clear, hey, this is one agent, this is a second agent, this is a third agent. You've clearly grouped the capabilities, and you can also start breaking it down into maybe what's a sub-agent or how you do agent handoff. Over the summer, San Francisco started talking a lot about context engineering, which is the art and science of giving your agents the right context in order to improve their accuracy. Context is kind of this Goldilocks problem, and what I mean by that is that it's easy to give your agents too little context so they don't have sufficient information to solve the problem you're putting in front of them. But it's also possible to give them too much context, and then they can get distracted or not know what to focus on. It has a lot of the same problems, honestly, as managing a human being. It's often the case that one morsel of bad context will drown out 10 bits of good context. So there's no perfect solution, but when you apply the tools of context engineering, your agent will be able to answer the questions in front of it better. One of the interesting questions is when you're spinning up sub-agents to solve tasks, do you want to share context between those sub-agents? And if so, how? You could imagine trying to delegate different parts of the problem to two different sub-agents and then them coming back with incompatible solutions. Again, this is a problem that often happens in human teams. One of the key things that if you're really focused on agent accuracy, you may want to do is just strictly sort of linearize your task. And then kind of when you're doing every new task in that process, compressing the context that was sort of provided at previous steps so that the agent at the point in the process where it's doing a task has access to the information that's around it. Between prototype and production, you play a lot of this number go up game where you're trying to get your agent accuracy higher to the point where you feel confident putting it in front of users. There are tools and techniques that you can use. Those tools and techniques are just as important as being able to evaluate whether they're working. A lot of like what we've seen teams do is they sort of classify various failure modes where the agent is not getting the right answer. And then they kind of work backwards to what is causing those failure modes. They have subject matter experts that are kind of helping them label and classify both test and sample sets, as well as looking at real production data. I mean, like real things that users are typing in. They're saying, hey, this is accurate, or this is not accurate, or here's how we would score this data. Those become the ground truth and the basis for evals that you can then judge your agent against as you iterate on your agent. Ultimately, if the cost of failure is high, and if you're shipping your agent not just into development but into production, we really recommend that you create a set of evals to test your agent's accuracy. The great thing is that recently more and more agents have been going into production. This concept of guardrails has emerged, which is basically looking at and scanning the inputs and outputs that you're sending into and getting out from your agent. Kind of the key thing that you need to be thinking about when you're building your agents is preventing this kind of like lethal trifecta. What that means is that if your agent has access to private data and it has access to untrusted sort of user input, and the ability to then send that data to an external system, those three things, then you need to be worried that someone with malintent could come in and sort of exfiltrate data from your system. The key to preventing that is that you can have any two of those three, but just guard and make sure you don't have all three at the same time. Agents have gotten a lot better in 2025, but they're still far from perfect. One of the big challenges that we haven't solved yet is known as agent learning. When you hire a human to do a job, they learn over time, and so they're better at day 7 or day 14 or day 28 than they were on day 1. But agents still don't do that yet. There's a few promising approaches to solve this problem, and I think we'll be a lot farther along in a few months. But I'm excited for the future because what's happening is that as more and more folks are gaining experience building agents and learning the principles and patterns of building them, we're just seeing this explosion of agents in all these different new fields that we haven't before. I loved what Andrej Karpathy said in the interview he did a couple of months ago, where he said it's not just that 2025 is going to be the year of agents, but 2025 to 2035 is really going to be the decade of agents. And so I'm just here looking forward to that and excited about what people are going to build along the way.